Here we discuss firstly the distinguishing point between a stable and monostable multivibrator. But in earlier lecture, we discuss in detail about the actual working and theory of a stable and monostable multivibrator. In this lecture, we only focus on some distinguishing points which come under a stable and monostable multivibrator. Here we give some differentiating point between these two types of multivibrator with the help of circuit connections. For a stable and monostable multivibrator, we use IC555. In both cases, these 8-pin connections of the IC555 are connected externally to the input supply, external components, resistors and capacitor, and output of the signal which is measured at the terminal 3. For a stable multivibrator, there are two resistors RA and RB which are connected in between the pins 6 and 8. When input supply is on, capacitor gets charges through the resistor RA and RB. Now we calculate what is the charging time constant, that is RA plus RB multiplied by C. Now as capacitor discharges through RB, we also note what is discharging time constant. That discharging time constant is RBC. Hence, in that way, we get the time for which the output of the timer becomes high, that is T on, and the time for which output of the signal becomes low, that is T off. We take the sum of T off and T on, we get the period of the output signal, and that we measure at the terminal 3. If we know the time period, then we find what is the frequency. It is the reciprocal of the period of the output signal. That frequency which depends upon the resistor RA, RB and the value of the capacitor C. In a stable multivibrator, here trigger is not given. It is shorted with pin number 6. For monostable multivibrator, here only one resistor which is connected in between the terminal 6 and 8 and the trigger pulse input which is given at the terminal 2. When the capacitor gets charges through the resistor R, we find the charging time constant RC and the charging time constant which control the width of the output pulse. Hence, in that case, we have to find what is the pulse width of the output signal for monostable multivibrator. That pulse width depends upon charging time constant R and C. Here, these 2 points we have to note here. The frequency of the output signal for the monostable multivibrator is same as the trigger pulse input given at the terminal 2. All these points we note in this article, and these are the differentiating points. Now we note some points. For a stable multivibrator, there is no any stable state. Therefore, that type of multivibrator is known as free running multivibrator. For monostable multivibrator, there is only one stable state and other state is unstable or quasi state. Hence, for one stable state, monostable multivibrator is known as one shot multivibrator. That we note here. For a stable, no stable state, therefore it is a free running multivibrator. While for monostable, if there is only one stable state, it known as one shot multivibrator. Second point, we note about the number of unstable states or quasi-states. For a stable, there are only two quasi-stable states. For monostable, only one state is quasi-state or unstable. For a stable, no triggering pulse is required, but for monostable, the triggering pulse is given or it applied at the pin number 2. Now we note what is the charging time constant. As capacitor gets charges through the resistor Ra and Rb, that charging time constant is bracketed term Ra plus Rb multiplied by C. When it discharges through the resistor Rb, the capacitor get discharges it's through the Rb and time constant is Rb into C. Therefore, we note what is the time for which the capacitor gets charges, that is T on, which depends on Ra plus Rb into C, and the time for which capacitor get discharges, that is Rb into C, that is T off. That will point the next point. For monostable, capacitor gets charges through the resistor R, therefore that charging time constant is Rc, and we know that charging time constant Rc which control the width of the output signal. Then what is the external components connected in a stable multivibrator and monostable multivibrator? For a stable multivibrator, there are two resistors Ra and Rb which are connected between the pin 6 and 8. We compare with the monostable, then we note here there is only one resistor which is connected between the point 6 and 8. Now then we find what is the frequency or the pulse width. Pulse width which depends upon charging time constant or the time for which the capacitor gets charges T on, that is 0.693 multiplied by Ra plus Rb into C. This is the pulse width for a stable multivibrator. For monostable, pulse width depends upon time constant Rc and it is 1.1 Rc. Now we find what is the frequency. We know that the frequency is the reciprocal of period of the output signal, that is 1 by t, and the t is sum of t on and t off. We combine together and we get 1 divided by 0.693 multiplied by Ra plus twice Rb bracket multiplied by C. Here the frequency depends upon the pulse width, hence frequency is 1 divided by 1.1 into R into C. Now then we see what are the applications of a stable multivibrator and monostable multivibrator. Here it is used as a rectangular square wave or ramp generator, while for monostable multivibrator it is used in industry for different timing application. Now these are the various points which come under a stable and monostable multivibrator. Thank you.